Okay, hello everyone. So this video is about the examples of Bode plot, and as I told you, I'm going to do an example here in this video, but I thought that maybe it's better to do more examples in class other than in video. So in this one I'm going to do one example for you so you can have some idea on how we can sketch the Bode plot, and then on Tuesday I'm going to do more examples in class. So this one is practice problem 14.3. Practice problem 14.3. So this is the transfer function that we have in this example. For j omega multiplied by j omega plus 10. Okay, so we have to draw the Bode plot of this transfer function, both the magnitude Bode plot and the phase Bode plot. So we can open table 14.3 on page 623 because I'm using that table always to draw the Bode plot. So that's one of the reasons that I want to do more examples in class, because I can show you the tables on board while I'm doing this, while I'm sketching the Bode plot. So the first thing that I told you in sketching the Bode plots is that these numbers should be equal to 1, right? So I have to factor out 2 from the numerator. So 2 multiplied by 5, this will be j omega over 2 plus 1 over, and then I have to factor out 10 from the denominator. So 10j omega multiplied by 1 plus j omega over 10. And you can see that this 10 will be cancelled with this 10. So we do not have any constant gain here in this transfer function. So the final transfer function that we have to draw the Bode plot for is 1 plus j omega over 2 over j omega multiplied by 1 over 1 plus j omega over 10. Okay, so let's see first for the magnitude plot. Let's see what each of these factors are. So what is this factor? This is a simple 0, right? And then we have the same configuration but in the denominator, so this will be a simple pole. And this one, 1 over j omega, is pole at the origin, right? At the origin. So now I have all the factors in the transfer function distinguished from each other, and we can go ahead and draw them. So for the first example, I'll just do it on a plain paper, but so in class I'm going to do it on the semi-log paper so you can see how we can draw on that paper as well, because in the exam I'm going to give you the semi-log papers to draw on. Alright, so for the magnitude plot, so you remember that we said in sketching the Bode plot, we have to sketch each of these factors individually and then add them graphically. So I'm going to draw each of these factors with one color and then add them graphically for finding the magnitude plot of Bode plot. So first one is the simple 0. So if you look at the table that we have on page 623, you can see that if we have a simple 0, which is 1, 2, 3, 4th row, it says that, oh, let me first specify the frequencies that we have here on the axis. 0.1, and then we have 1, 10, and 100. And then here is 20 decibel, here is 40 decibel. So the good thing about semi-log papers is that they have all of these already defined on them, so your graphs will be more accurate. Alright, so the first one was a simple 0. So for the simple 0, we know that the plot will be 0 until this 0 here, which is 2. So our 0, z1, is equal to 2. Okay, so if this is 1, this is 10, then this can be defined as 2. So it says that it is 2, right? And then after z, after the 0, it will increase with the slope of 20 decibel per decade. So it is basically 20n, but n here is equal to 1, right? So it is 20 decibel per decade. It means that from the frequency of 2 until the frequency of 20, okay, the magnitude should increase 20 decibels. So this will be our plot. And then again, from 20 to 200, it has to reach 40. So it is somewhere over here. See, since we don't have the semi-log plot, it is a little hard to draw them in the exact place, but it will be something like this. Okay, so this is our simple 0. Then we can go ahead and draw the simple pole or the pole at the origin. It doesn't matter. So I'm gonna draw the simple pole first. Let me change the color. What is our pole here? It is 10, right? So P1 is equal to 10. So for the simple pole in the table, which will be row 1, 2, 3, 4, fifth row, it says that the plot is equal to 0 until 10, and then it will decrease with the slope of negative 20n, and n is equal to 1, so it is negative 20. So from 10 to 100, it has to reach 20, which is here. So it's a little hard to draw exact line. And then from 100 to 1000, which is another decade, we have to reach 40. Okay, so this is my simple pole. So the only thing that is left is the pole at the origin, which is 1 over j omega. So let me draw it with another color, the orange one. Okay, so for the pole at the origin, it is the third row in the table. You can see that the slope is negative 20 and it has to pass frequency of 1. So when it is reaching frequency of 1, the magnitude is equal to 0, right? So this is 10, and then this is 20. So this will be my plot for 1 over j omega. Okay, something like this. Okay, now we have all our plots ready. So we have 1 plus j omega over 2, which is the green one. We have 1 over 1 plus j omega over 10, which is the pink one, right? And then we have 1 over j omega, which is the orange one. So now we can go ahead and add these graphs graphically. So you haven't seen this part before because the previous ones were like the things that I just talked about. All right, so let's add them graphically. See, the frequencies that something happens in the Bode plot are the frequencies that these plots will meet each other at those places. So one of them is the frequency of 1, another one is the frequency of 10, and I think that's it. Yeah, that's it. Okay, so let me draw these. It's not necessary to define these frequencies, but it will be easier for you to find out where the Bode plot has to change. So, oh, and also 1 at 2, right? They may or may not change at these frequencies, but if you define them, then you'll work more accurately. And let me change this plot here. It's a little too thick, so I get confused. Let me change it. Oops. Okay. So from 0.1, from the frequency of 0.1 until the frequency of 2, you can see that we have the green plot is 0, the pink plot is 0, but the orange plot is 20, and it is decreasing with the slope of -20, right? So if you add these plots together, if you add each point of these plots together, you will get the same plot as this one, right? Because the other two plots are equal to 0. So they don't have any effect on the Bode plot. Then, when we reach the frequency of 2, you can see that the orange plot is decreasing with -20. I will write here, -20 decibel per decade. The pink plot, it is 0, but the green plot, it has the slope of 20 decibel per decade. So what will happen here? We have one -20, we have one +20. So if we add them together, it will be 0. So we're going to have a plot with slope of 0. Okay? Until we reach frequency of 10. And then at the frequency of 10, we will have all three waveforms, all three plots, right? We have -20, and again, the pink one is -20 decibel per decade. And then we have the green one, which is 20 decibel per decade. So we're going to have 20 minus 20 minus 20. These will be -20 decibel per decade. So we're going to get a plot which is decreasing with the slope of -20 per decade. And from this frequency on, we do not have any other changes. So as you can see, we add these three plots graphically, and we got the black one, which is our Bode plot, the magnitude Bode plot, yes. So let me just make it a little thicker. So the black one is what we are looking for. So in the exam, for sure you have to show all these steps, and for sure all of them has some points, the partial credit, but to get the full credit, you have to be able to sketch this black one as well. So this was the magnitude plot. Let's go through the phase plot as well for this transfer function. So the transfer function was h of omega is equal 1 plus j omega over 2 over j omega multiplied by 1 plus j omega over 10. Okay, so this time we have to look at the phase plots in table 14.3. So you can see table 14.3, it has 3 columns. First one is the factor, so the factors that we have in the transfer function. Second one is the magnitude plot, and third one is the phase plot. Okay, so go ahead and look at the phase plots. All right, so let's draw the phase plot for each of these factors here in our transfer function. So omega, phi, 0.1, and then 1, 10, 100, and 1000. Why am I writing this like, why is the intervals from 0.1 to 1, 1 to 10? Because frequency is increasing in decade in Bode plot, don't forget that. So let's start from 1 plus j omega over 2, which is a simple 0, which is the 4th row in the table. You can see that the phase plot is going to remain, it will be 0 until z over 10. Sorry, I was looking at the wrong plot. So what is z over 10? z1 is equal to 2. So z1 over 10 will be equal to 0.2, right? So it says that if this is 0.2, it will remain at 0.2, correct? And then at 10z, which is, what is 10z? It is 2 multiplied by 10, which is 20. Okay, so at 20, it has to reach 90 n, and n is equal to 1. So this is my plot, right? So from 0.2 to 20. Okay, so how can I find the slope of this plot before it reaches 90? See, from 0.2 to 20, it's not 1 decade, it is 2 decades, right? First, from 0.2 until 2 is 1 decade, and then from 2 to 20 is another decade. So in 2 decades, we goes from 0 to 90. So we can easily say that in 1 decade, we would go from 0 to 45 degrees. Okay, so this plot here, it has a slope of 45 degrees per decade. So for sure here, it's not accurate here, but at 2, we're going to have 45 degrees. Okay, now let's go and draw for the pole. So 1 plus j omega over 10. So P1 is equal to 10, and P1 over 10 will be equal to 1, and 10 P1 is equal to 100. Okay, so 1, 2, 3, 4, 5th row in the table, it says that the plot should remain 0 until P over 10. P over 10 is equal to 1. So until the frequency of 1, my plot will be 0. And then it has to decrease and reaches minus 90 degree at 10p. So 10p is 100. So in 100, it has to reach negative 90. Okay, if I want to be consistent with the one that I drew for 0, I have to do this. It goes down. And we know that this one is the same as the other one, only the negative. So minus 45 degrees per decade. Okay, and then we have to draw the phase plot for the pole at the origin, which is easy. It is negative 90. So let me draw it with orange. It is negative 90. Okay, so these 3 are separate plots for each factor, and now I have to add them graphically. So let me specify the frequencies that something is happening in them. So it is 0.2, which is here. So as I said, there might be nothing, or we can't say that for sure at these frequencies the Bode plot will change, because if for example other ones are 0, then nothing will happen. So this goes to, and then 20 is another frequency, and then 100. Okay, so let's see what is happening here. So from 0.1 until 0.2, the green plot is 0, the pink plot is 0, but the orange plot is negative 90. So we're going to have this, because negative 90 plus 0 will be negative 90. Then from 0.2 until 1, we have the pink one is 0, so it doesn't have any effect. But we have a green one with positive 45 degrees per decade, while we have the orange one in negative 90. Okay, so the green plot will be shifted down here, right? Okay, and then from 1 to 2, or see for example, here is the example that I said they may not change. So from 1 to 2 and from 1 to 20, we have the same 3 plots. So the green plot, the pink plot, and the orange plot are not changing in the interval of 1 until 20. Correct? So we have the green one with 45 degrees per decade. We have the pink one with negative 45 degrees per decade. And then the orange plot, which is at negative 90. So those two will cancel each other. So we're going to have the same slope as we have for the orange plot. Right? And then from 20, we have the green plot at 90, and we have the orange plot at negative 90, and then the pink plot is negative 45 per decade. So it goes down like the pink one. Okay. And then at 100, we're going to have negative 90 for the pink one, negative 90 for the orange one, and positive 90 for the green one. So we're going to have negative 90 for our Bode plot. So for the phase plot, you may be a little confused in the beginning, but I'm going to talk more about it on Tuesday because I want to draw it on the semi-like paper so you can see what's going on better. Okay, so please watch these videos before Tuesday class because I want you to have an overview on what the Bode plot is and how we can draw them. Thank you.